Okay, hello everybody, welcome to the lesson, and we are going to have the lesson as online for a while. So today I'm gonna talk about binomial expansion, and the first part is Pascal's triangle and binomial expansion. Okay, you can see the numbers here, and then we are going to start with the 1, and after that, for the each part, I'm going to write the corners once, and after that we will take the sum of the numbers. 1 plus 1 is a 2, 1 plus 2 is 3, 2 plus 1 is 3. These numbers actually will be the coefficient of the terms. For example, here is, let me show you. Okay, so what is a to the power of 8 plus b to the power of 0? It's gonna be 1, right? Okay, so if you will find a plus b to the power of 1, it will be itself, right? A plus b. So look at the coefficient of a and b. It's a 1 and it's also 1, right? You can see here. To find a plus b square, it will be a square plus 2ab plus b square. I want you to look at the coefficients here. What is the coefficient of a square? It's a 1. Okay. And what is the coefficient of 2ab? It will be 2. And for the last one, b square, which is 1, right? Okay. It's gonna be the second power. Okay. If we'll find the power of a plus b cubed, so it's gonna be a cubed plus 3a squared b plus 3ab squared plus b cubed. Please focus on the coefficients. So it's gonna be 1. Okay, after that comes 3. Okay, got this, and the 3 and the 1, right? Okay, as you see here, for the each step from left to right, we are decreasing the power of a and we will increase the power of b. Here first we take the cube of the first term, which is a cubed, and after that comes the coefficient, which is 3. We will decrease the power of a 1, so it's gonna be a square, and we will add b. For the next step, the power of 2 will be here as the 1, and when we add the power of b 1, so it's gonna be 2. And for the last, we will have a to the power of 0, which is 1, and we will increase 1 power of b squared, so which is b cubed. Okay, that is our Pascal's triangle. So by the way, we can find very large power of the expressions. For example, a to the power of b, a plus b to the power of 11. Also, we can find, we can expand the expression here. Okay, so let's move on. And here is one important point, which is the expansion of a binomial expression to the nth power has the following properties. There are n plus 1 terms in the expansion. Okay, so it means that if we are going to find how many terms are there in this expansion, x plus y to the power of 12, the power is 12, and to find the number of terms, we will add 12 and 1, which is 13 terms. Okay, take example 102. Okay, so after that, to expand 2x plus y to the power of 6, and directly I will go the sixth power. It's here. Look at the coefficients: 1, 6, 15, 20, 15, 6, and 1. I'm going to take over it. And after that, so first we will take the sixth power of the first term, which is 2x to the power of 6, and plus write the coefficient, which is 6. And after that, 15, 20, 15, 6, and 1, right? Okay. As I told you before, we will decrease the power of the first term for the every single step from left to right. So here the power of first term is 6, and after that, for the second part, it's gonna be 5. For the next part, 4 is 3, 2, 1, and 0. And after that, we will increase the power of y. So here the power of y is a 1, and after that, 2, 3, 4, 5, and 6. Okay. So 2x to the power of 6 will be 2 to the power of 6 times x to the power of 6. And when we simplify here the expressions, multiply, use other operations to get the result, which is, you can see the result here. Also take example 103. Okay. So the next example 104, we will expand x squared minus 3y to the power of 4. It means to find the fourth power, I will go directly to Pascal's triangle. Look at the row here. Take the coefficients 1, 4, 6, 4, and 1. Okay. And after that, we will start with the first term, take the fourth power of the first term, which is x squared to the power of 4, and after that, write the coefficients. And as the difference of the terms, it means that we will take minus, plus, it goes like that, okay? So we will write the second coefficient, which is 4, and after that take the cube of the first term, which is x squared to the power of 3, and multiply the number by the second term, which is 3y, and plus 6 times x squared to the power of 2, decrease the power 1. Here it was 3 and it becomes here 2, and increase the power of second term, which is 3y to the power of 2 minus 4 times x squared times 3y cubed plus. And for the last part, it's gonna be, we will take the fourth power of the second term, which is 3y to the power of 4. That is a basic mathematics, you know, you're a science class, so all you need to do is multiply and find here the powers. You can see the result. Take 104. Okay, for example 105, we will find the seventh power of n plus 1 over n. Take the coefficients, and we have actually same story. Okay, and check yourself 13. It is homework for the next time. Okay, so also we can expand the terms by using combination. You are gonna see here the formula for the combination. That is the combination part. X plus y to the power of 0. We will take the combination n0, n1, n2, n till n minus 1, and the others is same. So when we find x plus y to the power of 6 by using the combination, the combination 6, 0, what is it? Combination 6, 0, it's gonna be 1, so 1 times x to the power of 6. After that, we will take the combination 6, 1, 6, 2, 6, 3, 6, 4, till 6y, y, because the power is 6, and we will subtract from the power 6, 1, so it's gonna be 5. So it means that when we start to take the combination from 6 to 1, we will go till 6 to 5, and the others is same. Okay. Example 108, take it. And for the next example, 2a minus b to the power of 5. Okay, we have the same story. 2a to the power of 5, combination from 5 to 1 till 5 to 4, because the power is 5. Take difference between 5 and 1. Okay, example 109, take it. Important. Okay, so here you are gonna see the arts entry in the expansion of x plus y to the power of n is, you're gonna see here the rule. So let me clear it by solving this example 111. You are gonna see here the expansion a plus b to the power of 12, and we will find the ninth term. So to find it, actually, we have to define the value of n and r. After that, we will put in the original formula. So n is 12 because we will find the 12th power, and the r is 9. Why? Because we will find the ninth term. So it's gonna be combination 12 r minus 1, which is 9 minus 1, times x to the power of, take difference between n and r minus 1. And after that, we will find y to the power of r minus 1. So combination 12, 8 will be 495, and x to the power of 12 minus 9 is 3, plus 1 is 4. The power will be 4. What is the first expression? A. So we will take a to the power of 4, and the second b to the power of 8. Okay, I like it. That's great. That's great. Okay, so we can find also the sixth term, combination 9, 5, 2x to the power of 9 minus 5, and y to the power of 5. So it's gonna be 2016 x to the power of 4 times y to the power of 5. Okay, so to find here the coefficient of the sixth term, what are we gonna do? We will take just 2016, right? So it means that the coefficient of the sixth term will be 2016. To find it, we have to find the sixth term. So you are gonna see here the question 113. We will find the coefficient of the fourth term. First, we have to find the fourth term. What is it? 35 times 16 times and negative 64. To find the coefficient, we have to multiply 35, 16, and negative 64, which is negative 35,840. Okay. Also, I want you to take check yourself 14. Okay. Thank you very much for the lesson. That's enough for today. See you on the next lesson. Bye bye.